Hello, and welcome to this last in a series of tutorials intended for citizen scientist amateurs that show how to use satellite images to monitor changes in vegetation extent and condition. Here, we will demonstrate how to quantitatively estimate land cover extent and condition. Before we get started, here are the other tutorials in this series. Check the description below for links to these tutorials. As you hopefully recall from the introduction to this series, our goal has been to help citizen scientist amateurs use satellite imagery to track changes in the extent and condition of vegetative land cover. Well, we are finally ready to show how to estimate vegetative land cover extent and condition. The previous tutorial in this series described how to distinguish among different land cover type clusters. In this tutorial, we will show how to estimate the extent and condition of these land cover type clusters. To calculate condition, we will be using the three vegetation indices calculated in an earlier tutorial. Here, we will apply these indices to the land cover type clusters that we found within our region of interest. We'll start off by creating a QGIS project. In this project, we import the 5-cluster raster layer that we created in the previous tutorial and a folder where we import the 3 vegetation indices that we created in a previous tutorial. We also create groups for the cluster masks and indices by land cover type that we will generate here. Now we'll estimate the extent of the land cover type clusters, which is a pretty easy task. If we look at the layer properties for the 5-cluster layer, we see that the pixel size is 30 by 30 and that everything in the project is in meters. Using this information and the pixel counts for the 5-cluster model from the previous tutorial, we can estimate the extent in acres of our 5 land cover types. As verified by visual inspection of the 5-cluster raster layer, the dark green cluster 4 has the greatest extent in the region of interest with a total of 4,486 acres, or 41% of the region of interest. As we have been saying, we wouldn't know what the actual cluster land cover types are for these clusters, except for water, until we walk out to see what they are. But we do now have an estimate of the extent of each land cover type. Now we'll move on to estimating land cover type condition, which is a bit more involved than extent. We'll start by making raster layer masks for each cluster. You'll need to wait until step 3B to see why we make these masks. Let's make a cluster mask for cluster 1. This can be done by using the export tool to export a particular cluster layer to an associated mask layer. To create the mask, we assign the unwanted cluster numbers to no data. Since we want just cluster 1 in this export, the no data clusters are 2 through 5. Here then is the cluster 1 mask, which contains values for only the pixels falling into cluster 1 and no data for all other pixels. It has been colorized to match the original 5-cluster layer. This step is repeated to create cluster masks for the remaining 4 layers. We now have 5 masks that cover the entire region of interest. As a quality check, all the masks have been colorized to match the 5-cluster layer, So when turning on all 5 masks, the results should match the original 5-cluster layer. Our next step is to apply the masks to the vegetation index layers. We'll start by applying the cluster 1 mask to the NDVI index. This is done in the raster calculator, where here the NDVI raster is being clipped by the cluster 1 mask. And here is the NDVI raster layer trimmed to just cluster 1 with no data values for all of the remaining clusters. The colorization on this layer is -1 to 1 because we know that NDVI ranges between these values, with +1 being healthy vegetation and -1 being bare ground or unhealthy vegetation. What we see is that the land cover type associated with cluster 1 appears to be pretty healthy, but just how healthy is it? Our final step is to extract the condition measurement values from our masked vegetation indices. If we open the layer properties for the cluster 1 NDVI layer and scroll around to the statistics section, we see that the mean NDVI value for this layer is 0.8, which indicates a very healthy vegetation land cover for this vegetation type. Repeating this procedure for the other vegetation indices and land cover types, and disregarding water regions, we can get a profile for vegetation condition in this region of interest for August 15th, 2023. With that, we have characterized land cover type, extent, and condition for this region of interest and date, and have thus concluded our demonstration of how satellite imagery can be used to estimate land cover extent and condition for various land cover types. What next? Well, now it's time to go out into the field to figure out what these land cover type clusters are associated with in nature. Having achieved the primary goal of this tutorial, you may want to check out the summary to review what we have accomplished here. Please note that this series of tutorials would not have been possible without the generous assistance of staff at the USGS Earth Resources Observation and Science Center. If you have questions on how to use Landsat data, contact their customer service. All Landsat data used here courtesy of the U.S. Geological Survey. Thanks for watching this video. See the description below for links to all of the tutorials in this series.